So this little video is a kind of insert between section 2.3 and 2.4, and it could have also gone with section 2.2. We have cause a lot of times to find the minimum or the maximum value of a quadratic. If you're thinking about section 2.4, that would also be the turning point of the curve. And when we get later into the book and look at the differentiation chapter, we find there's another method for doing this. But it's often sort of easiest to do it in this kind of way, which is, if I've got a quadratic like x squared plus 6x minus 5, what I'm going to do is complete the square. So I'm going to say, well, b is 6, b over 2 is 3, b over 2 all squared is 9. So taking those two terms there, I get x plus 3x all squared, take away 9, and then minus 5 there. So x plus 3x squared minus 14. So that's my quadratic expression. I've completed the square on it. So if I have a function, f of x equals x squared plus 6x minus 5, that's exactly the same as this function. Now, if I want to know the minimum value of this function, then what I want to know is, sorry, I've thrown an extra x in, haven't I? There we go. If I want to know the minimum value of this function, what I'm saying is, what is the lowest value that this thing here can take? And when I look at it, it's split up into two parts. This bit, and then a minus 14. Now this bit is something squared. If you square something, it's got to be positive. Any number that you take and square it is positive. So, it's positive or 0. The lowest value that this bit can take is 0. So that bit is 0 or more. So I've got minus 14 added to, or if you like taken away from, I've got a number, minus 14, and the number has to be 0 or bigger. So the smallest value that the whole thing can take is going to be minus 14. And when does it take that value? Well, it takes that value when this bracket, excuse me, takes that value when this bracket here is equal to 0. And that bracket there is equal to 0 when x equals minus 3. So the lowest value that this function can take is minus 14. It happens when x equals minus 3. If you're looking for the turning point of the graph, then it's minus x equals minus 3, y equals minus 14. Okay? Now, I know that that one has a lowest point because of everything we just said. It's minus 14 plus a number here. If you have a completed square form, say something like this, x plus 4 squared minus 6, if that is, or let's even make it a plus 6 there. If there's a minus sign in front of this bracket here, then when I expanded the bracket out, I'll have a negative coefficient of x squared. And we should know that as a graph, that would look like an n-shaped parabola instead of a u-shaped parabola. And also, if we just go through the same reasoning, well, I've got here a 6 and this bit. This bit here is something squared and then minus. So this has to be negative because it's 0 or positive, and then we times it by minus 1, so we make it negative. So this is 6, take away something positive. So the maximum value that this can get to is 6, and that happens when x equals minus 4. So minus 4, 6 is the maximum value of that expression. So if I have this function, the maximum value that function can take is minus 4, 6. Okay, so turning points from completed square form, turning points of quadratics, or maximum or minimum value of quadratic functions, completed square form is what you want to think. And somehow in your head you want to label those two things together. So when a question is asking you for a turning point, you think, I'll complete the square. When a question asks you for a maximum or minimum value of a quadratic, you think, I'll complete the square. Okay? Next video will be section 2.4.